Okay, this is the P4 paper from January 2023. It's question number 6, which is a vectors question. First part is finding the vector equation of a line in 3D, and then we're going to be solving some geometrical problems in 3D. But let's have a read through of it and get started. So it says we've got point A, which is 2i minus 3j plus 5k. We've got point B, which is 8i plus 3j minus 7k. And it says L passes through A and B. Can we find the vector AB? Then can we find the vector equation of the line L, which passes through them? Yep, we can actually do that. So part A. What I tend to do with these is just draw a quick sketch out, because I might need this for the later parts to it, which is, I'm not going to bother doing all 3 dimensions in, but if I've got a vector A, little a there, and a vector B here, this should be no surprise to you at all. If I want to work out the vector AB, which is the first part, part 1, the vector AB will also always be, B minus A. Now I'd rather use column vectors than IJK notation. I just make less mistakes with that. Got a choice, we can do what we want. So here, the column vector is 8, 3, minus 7. Minus the other column vector is 2, minus 3, 5, which gives me my answer for AB to be 6, 6, minus 12 here. And I just prefer to write it in that format rather than try IJK notation. It's just preference. You can do either way when you're doing these questions. So that's part AB. And then the second one is to actually find the equation of the line that passes through those. Let me just tidy that up on. So we actually want the line L here, which passes through AB. Now, if I want the vector equation of a line, what I need to do is to get on the line and then go up and down it. I can get on the line by A, or I can get on the line by B and then go up and down it. How am I going to show that to the examiner? I tend to use this notation, so part 2. If I want the vector equation of a line, I say R is equal to P plus lambda Q, where that one is either little vector A or little vector B getting onto the line, and Q is actually what we've just found, is AB, the direction of the line. So if I'm doing this, I'm going to say R is equal to, so I've got a choice. I'm actually, for no reason, I'm just going to choose 2 minus 3, 5, plus lambda lots of 6, 6, 12. You could just as easily have used 8, 3, minus 7. They both will be answers given in the answer book. Okay, so that's the vector equation of the line for part 2. Okay, now the reason behind drawing this diagram is really for second part B, when we're looking at it. So it then says, C has a position vector 3i plus 5j plus 2k. So I don't know where that is, but what I do know about it is it says P lies on L. So I'm going to put P here. I'm going to say P, should put it so it's not in the way. P is going to be there, and P lies on L, and CP is going to be perpendicular. So if I now say that C is there, just for the sake of my diagram, doesn't have to be overly neat here, then CP is perpendicular to L. I'm going to get that CP dotted with AP is going to be equal, dotted with AB, sorry, is going to be equal to 0 later on. What we've got to do is to try and find the position vector. We're trying to find the position vector of that point. We're trying to find what the position vector of P is. Okay, a little bit of work involved in doing this then. So first thing I'm going to do is to say, if I want to work out CP, CP is going to be P minus C, the same way as before. And the point P, I can represent it using that, because it lies on that line. I can represent it using that. And what I'm actually going to do is put that together. So I'm going to say 2 plus 6 lambda. I'm going to say minus 3 plus 6 lambda. And I'm going to say 5 minus 12 lambda. Just going to explain where that comes from. If I keep them both on the screen there, that's from there. Okay, so P is a general point on the line, so it can be represented by that, minus C, and C was 3, 5, 2. Okay, so if I actually subtract those away from each other, then I'll get CP in terms of lambda, but I'll get CP. So CP works out to be 6 lambda minus 1, 6 lambda minus 8, and minus 12 lambda plus 3. Now what I know about CP then is if they're perpendicular, CP dotted with AB must equal 0. We use that a lot for the dot products. So 6 lambda minus 1, 6 lambda minus 8, minus 12 lambda plus 3. That dotted with AB, which we had previously, was 6, 6, minus 12. That's going to be equal to 0. And now we can tidy that up to get a value for lambda. So if I multiply all that out, I get 36 lambda minus 6, 36 lambda minus 48, 144 lambda. Okay, so just take your time over things like this. It's fine, it's a P3 exam. No problem with taking a little bit of time to do the algebra here. I'm getting 216 lambda there, minus 90 is equal to 0. So lambda works out to be equal to 5 over 12. You just need to tidy up that algebra, obviously. And then what did we want? We want the position vector OP. So we still haven't got that yet. So OP is going to be, let's just have a look at this. Okay, if I want to get there, OP is going to be, now that I know what lambda is, it's going to be 2, 3 minus 5 plus lambda lots of AB will give me what I'm actually looking for, which is the position vector OP. That's what I'm trying to get. So let's just explain that to the examiner then. So OP is going to be A plus, no, sorry, we did it as, yeah, what did we say it was? Sorry, P plus lambda lots of Q, I'm going to say. P plus lambda lots of Q, but this A plus lambda lots of B, when I say it's going to be 2 minus 3, 5, plus lambda lots, well, we know what lambda is, 5 over 12 lots of 6, 6 minus 12, I think that is. And then just work that all out, and OP works out to be equal to, that's 4.5, it's minus 0.5, and the bottom one actually cancels. The bottom one actually cancels out to be 0 there as the actual position vector. Now they might have it in terms of I's and J's, but as I say, I just, for me, I'm less likely to make a mistake when I'm doing it using column vectors, and I'm allowed to choose whichever one I want to do. So yeah, hopefully that all makes sense to you.